Hello, it's me, Mrs. S, and today we are going to be looking at hydrographs, one of my favourites. So let's have a look at a 10-second taster. What do you actually need to know? It's about the use of hydrographs and how they show the relationship between precipitation and discharge. So we're going to be talking about lots of key terms today, so make sure you've got plenty of revision materials, pens and pencils, and let's get started. So a hydrograph is a graph designed to show the relationship between rainfall, precipitation, and discharge. And discharge is an absolutely key term. It means the amount of water that is actually running through the river at a given point in time. And this is measured in cubic meters per second, or cumex. So as you can see, along the x-axis here, we have the number of hours to sort of measure the duration of the rain event and what and how the river is responding to that rain event in terms of its discharge. So another key element of the hydrograph is the lag time, and this is the difference in time between the peak discharge, so when discharge is at its highest, and when rainfall is at its highest, or peak rainfall. So if we take for an example here, if we imagine that peak rainfall happens at 5 hours into this whole kind of event, and the peak discharge occurs 20 hours into this event, that gives us a lag time of 15 hours, 20 take away 5. And that means it took 15 hours, essentially, for all of that rainfall to reach the maximum discharge, to reach the river. So peak discharge is really important, and it's really important that we read off and look at all the clues about this event, this rain event. We look at the shape and steepness of the rising limb, that is the upward trajectory, if you like, of the discharge line, and then the falling limb, the shape and steepness of the falling limb. The steeper it is, the shorter the lag time, and the higher the discharge, obviously the more rainfall got into that river. So let's have a look at some scenarios. In this first scenario, we're looking at a heavily forested drainage basin. So where this river is flowing and where this rain took place, we've got lots and lots of forest, and that means masses of interception. So actually, in terms of the lag time is going to be a lot longer because it's taking the water a lot longer to reach the river. You can also see that the discharge line didn't get particularly high, and that's because the river, as we know, is the water is intercepted by the trees, and the trees store that water. So let's look at scenario 2, a highly urban drainage basin where we've got lots of concrete, we've got lots of impermeable surfaces, lots of drains, and that's really funneling all that water via surface runoff into the river. So you can see the lag time is really short because it didn't take very long for all that water to flow over those concrete surfaces and reach the river. And the discharge line has got a lot higher. And that's because all of that water filled up the river very quickly. So the discharge is higher. So with this one, we're likely to be looking at a flash flood. Scenario 3 then, very similar, lots of deforestation, so we've got lots more surface runoff. So again, a short lag time and a higher discharge line because there was no interception or a lack of interception to really hang on to that rainfall and prevent it from reaching the river quickly. So this is something we might associate with areas which are experiencing high levels of deforestation. And our final scenario today is low stream density. So that means this is probably an area of quite permeable rock and porous soils which are draining the ground quite easily. So we haven't got much tributaries and other smaller rivers running along the surface of our drainage basin. That means it's going to take a lot longer for the water to drain through the soils, through those rocks and into nearby rivers. So we've got a much longer lag time because of that slowing effect, and we've got a lower discharge because it's going to take a lot longer, and much of that water might get actually stored in soil or as groundwater or in aquifers on its way to the river. So another whistle-stop tour today of hydrographs. Hope that's been helpful. Stop and pause the video now and have a look at these revision questions. Anything you don't get, go back and rewatch the video again, and I'll see you really soon for another video of Hans Mum's Geography. Don't forget to like and subscribe. Thank you.